Good morning, students. Welcome to Daffodils Concept School and Pre-University College. PU Second Year Physics, Chapter name Dual Nature of Radiation and Matter, Class number 9. Today's topic is about construction and working of Davison-Germer experiment. Davison-Germer experiment. Here I have given the diagram. Just you observe that what are the apparatus they have used. The first one is high tensional battery. Next one is low tensional battery. Here electron gun and a filament, a nickel target, a collector that is placed on a circular scale which measures the angle, and here movable collector is there. The movable collector is connected to the galvanometer. What are the apparatus? High tensional battery, next low tensional battery, filament, electron gun, here it is the cylinder, next nickel target, and here movable collector or detector that is placed on a scale, circular scale, and here a galvanometer is connected, and here electron gun, movable collector along with the galvanometer, and nickel target. This part is placed in a evacuated chamber so that there will be no other particles, so that electrons cannot collide with them. In this diagram, if you observe the electron gun part, which is comprising of tungsten filament, which is connected to a low tensional battery. When a filament is connected to the low tensional battery, whatever the low voltage power supply is there, that heats the filament. If the filament is heated, that emits the certain number of electrons, and along with electron gun consists a cylinder which helps to move the electrons in a particular line or in a particular direction. Along with that, the electron gun is connected to the high tensional battery. The high tensional battery accelerates the electrons. Here low tensional battery heats the filament so that filament emits the electron with a certain velocity. Here when the electron gun is connected to the high tensional battery, whatever the high tensional battery is there, that provides the high voltage values. When they provide the high voltage value, whatever the electron is there, that velocity will be increased, so that we'll say that one, the electron is accelerated, means that here we are going to provide the accelerating potential, so that the electrons will be coming out of the cylinder with the maximum velocity. We will say them as the accelerated electrons in the form of a beam, means that a group of electrons will be there. They will pass along a straight line through the fine holes of the cylinder, and they will strike the nickel target, whatever it is placed here. When they strike the nickel target, they will be deflected by certain angle. They are received by whatever the scattered electrons are there. They are received by the detector. Here, is it possible to receive the electrons at this point only? No. I said that one, whatever the collector or detector is there, that is a movable collector. Movable collector means it can move to any point, so that at what points the electrons are coming to us to that one, at that point only it will move and it detects them. When they are detecting the electrons, the amount of current is measured by the galvanometer. Here galvanometer measures the small values of the current, along with it gives the direction also. If they use the here circular scale, means that gives the angle of scattering. Here you can observe that one, here theta they have mentioned, that is nothing but a scattering angle. Here we have the construction part of the Davison-Germer experiment. The experimental arrangement is as shown in the figure. It consists of an electron gun which comprises of tungsten filament. The filament is coated with what? Barium oxide and heated by a low voltage power supply. That is nothing but I said that one as a low tension battery. Low tension battery means which provides the low voltage value. Next, the electron gun is connected to the high tension battery which provides the high voltage value so that the electron can be accelerated with the highest values of the velocity. Next, the nickel target is placed at a suitable distance from the gun. Next, the movable electron detector with a sensitive galvanometer is placed such that the scattered electrons are collected at different scattering angles. Then the entire apparatus is enclosed in an evacuated chamber. Why? Because whatever the electrons are there which are coming out of the cylinder, so that if they placed in evacuated chamber they cannot scatter or they cannot collide with the other particles. Here whatever the scattering angle is there, that is measured by the circular scale. Here we have the working part of the Davison-Germer experiment. The electrons which are emitted from the tungsten filament, they are accelerated to a desired voltage by applying, you make this point as the velocity. What is this point? Desired velocity. What is this point? Velocity. Desired velocity. You make this point as the desired velocity. Here instead of voltage you make this point as the velocity. Whatever the electrons emitted from the tungsten filament is there, that electron is accelerated to a desired that is a desired velocity to a highest velocity, that is accelerated by connecting or else by using the suitable, that is the highest potential, or else we'll say that one as a voltage, by using what? High voltage power supply. And they are made to pass through a cylinder with fine holes along its axis, producing a fine collimated beam. The beam is made to fall on the surface of a nickel crystal. The electrons are scattered in all directions by atoms of the crystal. The intensity of the electron beam scattered in a given direction is measured by the electron detector, or else we will say that one as the collector. The device which receives or else which collects the electrons coming to us, to that one is nothing but here electron detector, or we will say that one as the collector. The detector can be moved on a circular scale. Then the galvanometer records the current. You may think that one ammeter measures the current. Why they didn't use the ammeter? Ammeter measures the current, but if you want to measure the very lowest values of the current, go for the galvanometer. Galvanometer gives the direction of the current also, so that they have used here galvanometer. The deflection in the galvanometer is proportional to the intensity of the electron beam. Whatever the deflection in the beam is there, means that initially it is at the exactly at the 30 degree. It may move leftwards or else it may move rightwards. That is depending on the intensity of the electron beam. If electron beam intensity is very high, if intensity of electron beam is very high, the deflection will be more, means that the needle will show the highest reading when the intensity is high. If the intensity is low, it shows very less deflection, means that here the deflection in the galvanometer is proportional to the intensity of the electron beam entering the detector. The intensity of the scattered beam is measured for different angles of the scattering theta, which is the angle between incident and scattered electron beams. Here you can observe the video. The low tension battery, or else a low voltage power supply which heats the electrons, which heats the filament, so that the filament emits the electrons. Whatever the electrons are there which are emitted from the filament, they are accelerated by the high tensional battery that is connected to what? That is connected to electron gun. When it is connected to the electron gun, it provides the high velocity for the electron. Those electrons are coming out of the cylinder. You have observed here, whatever the electrons are there, they are coming out of the cylinder with a high velocity. They are nothing but accelerated electrons. Those accelerated electrons are striking the nickel target. The electrons which are striking the nickel target, they are scattering at the different points. They are received by what? You can observe here, movable detector. Why it is said movable detector? Why? Because it is reaching to a point where the electron is reached. At that point only the detector receives the electron or collect the electrons. Here you can observe the movable scale. Here on the scale you can observe the dotted line which indicates the angle. You can measure the scattering angle by using this movable scale. Movable scale is connected to the galvanometer. Here the galvanometer is at the left end, means that if the intensity is more, whatever the here left end is there, that is left part is there, if intensity is more, then only it indicates the maximum deflection. That intensity is measured by the galvanometer deflection. If there is no intensity, means that if the electron is not emitted, then whatever the galvanometer is there, it shows zero deflection. Here the galvanometer is indicating the left side maximum, means that here intensity is maximum. It will not be at the left end or else right end, it will be at the center only, at this point only. When it is at the center, it indicates a low intensity is there. If it is indicating the left end or else right end, it indicates that highest value of the intensity there. The variation of the intensity of scattered electrons with the angle of scattering theta is obtained for different accelerating voltages. They are going to take the different accelerating voltages and they are going to observe the angle of scattering theta, and the variation is measured. It was noticed that the intensity of the scattered electron beam is very high, that is a maximum, for an accelerating voltage of 54 volt at a scattering angle of theta is equals to 50 degree. What is that condition? When they have given accelerating voltage is equals to 54 volt, they have noticed that intensity of the scattered electron beam is very high. How they have observed? I said that one galvanometer needle, whatever the galvanometer deflection is there, if it is a maximum, then we can say that one intensity is a maximum. If the deflection is zero, then you can say that one intensity is low. They have observed that one, whatever the galvanometer is there, that shows the maximum deflection when the accelerating potential is at the value of 54 volt. That is by using the high tensional battery, we are going to accelerate the electron, means that when they have given 54 volt, there was a highest intensity that is observed in the galvanometer deflection. At that point, the angle, that is scattering angle, is equals to theta is equals to 50 degree. The intensity is maximum in a particular direction is due to the constructive interference of electrons scattered from different layers of regularly spaced atoms of the nickel crystal. From Davison and Germer experiment, the wavelength of electron was found to be 0.165 nanometer. From the Davison-Germer experiment, by using the Bragg's equation, they have calculated the wavelength and they got nearly 0.165 nanometer. But from the de Broglie wavelength of electron, was found to be 0.167 nanometer. That is, here you can observe this one. We have the de Broglie wavelength equation. Lambda is equals to what? H divided by square root of 2m ev. H is what? Planck's constant. M is mass of the electron. E is charge on the electron. V is accelerating potential, or else whatever the potential is applied. When the H value is substituted and M value is substituted, E value is substituted, and if you simplify that one except the V, you will get nearly 1.22 into 10 to the power minus 9 meter. Here that is written. Here except the V value. Why? Because in this experiment we are varying the potential value, that is accelerating potential value. H is constant, mass of the electron is constant, next charge on the electron is also constant, so that if you calculate all those value, that is you will get nearly 1.22 nanometer divided by square root of V. V is what here? Accelerating potential. For what value we got the maximum intensity? That is for the 54 volt. When you substitute this one, that is 1.22 divided by square root of 54, we are observing here 1.22 divided by 7.348, that is square root of 54 is equals to 7.348. That is equals to, if you take the ratio of these two, we can observe that 0.167 nanometer. This is from the de Broglie explanation. That is, if we use the de Broglie wave equation, we got this one. But in the Davison-Germer experiment, the experimental value is around 0.165 nanometer. But from the de Broglie wave equation, we got nearly 0.167 nanometer. If you observe these two values, you will come to know that one, they are very near to each other. So that thus there is an excellent agreement between the theoretical value and experimental value. Experimental value is nearly 0.165 nanometer, but the theoretical value, by using the de Broglie wave equation, we got nearly 0.167 nanometer. Davison-Germer experiment thus confirms the wave nature of electrons and the de Broglie relation. Up to here, you have to make the working of the Davison-Germer experiment. Now, once again recollect the working of the Davison-Germer experiment. They have connected a low tension battery to the filament. Filament heats and it emits the electrons. The electrons which are emitted from the filament are accelerated by the high tensional battery, which provides the high voltage, so that the electrons are emitted with the high voltage through the cylinder. Whatever the electrons which are coming from the cylinder, they are going to strike the nickel target, and they will, when they strike, they will be scattered. When they scattered at the different points, they are absorbed by the movable collector, which is placed on what? That is a circular scale. Circular scale is also connected to what? Galvanometer. The galvanometer shows the deflection. If galvanometer shows the maximum deflection, it means that intensity is maximum. Experimentally, they found that the galvanometer has shown the maximum deflection when the accelerated potential is equals to 54 volt. So that scattering angle is also equals to 50 degree. This is about the construction and working of the Davison and Germer experiment.